I will not do a PowerPoint presentation. I will use CollaBoard for that. So CollaBoard is not only something that you can work together, but you can only work for your own, okay, and do some stuff. So we showed you a little overview what we are doing and where we are going to. And I think that the world is really changing now. We are in the middle of something where IT or software or hardware is really, we are at a new level now. In the next few years, the whole market, in my opinion, will completely change. And also how you work together as a user, how you do stuff, this will completely change in the next 2, 3, 5, 10 years. Okay? If this is positive or not, I don't want to discuss that. It will just happen. Okay, and we have to adopt to that. We have to adopt to that our personal processes, but also our business processes. And the companies who will not go with this fast evolution which we have now, they will have probably more troubles than other companies. So I load here also a CollaBoard project. I hope I can do that. Okay, so yeah, so I like this stuff. Okay, okay. So I don't want to make a new project. I load an existing one, and I have a key. I don't use page, or I type quite conventionally for the moment. And you see this Cortana thing and the speech recognition. This is all good. It's really cool, but it's at the beginning. Also like the HoloLens, it's in the beginning. But it goes very fast. Imagine 10 years ago, 2006, there was no iPhone. Can you imagine that? That was just 10 years ago. So you have to understand what happened now in these 10 years and how fast this goes. It's not just that the processors will be faster and we have now i5, i7, 8-core and I don't know what. It's the complete industry which is going really very, very fast at the moment. So I enter this key to load this project. Huh? Oh, okay, thank you. So, okay. So we are loading now from Azure, from the cloud. So cloud, I have no clue where this damn thing is. I have no idea where my data is. Okay, do I care? Well, if you would ask me 5 years ago that the customer database we have is somewhere and I have no idea where it is, I would say, oh, no way. Today, I know it's encrypted, it's somewhere, but it's somewhere in Europe, we know that, so it's somewhere where it belongs, and so it's secure. It's maybe more secure than in our office, and if somebody wants to really hack, he can hack us, or he can hack this. So I think this will also completely change. So what do we see here? So this is how the whole thing started. Okay, IT. Do you know what this is? Hmm? It's similar. Good guess. Okay, so this is a computer. This is a computer which was built in 1690. 1690. It was built from a scientist called Leibniz. Maybe you ever heard about this name. Leibniz was a guy, a very brilliant guy, and he built this mechanical computer. This was working. So you could add and multiply and whatever, and maybe you say, oh no, but we had 2,000 years ago, we had this abacus from China, where you could also do some computing. But this was, in my opinion, this was the first computer we had, and he did also a prototype of a computer based on the binary system. With 0 and 1s, it never worked. It was too early. It was not possible to build on a mechanical base a computer which has the power as today. This changed several hundred years later when manhood, when we understood what electricity and magnetism is. And only with that we understood that, it was possible that we started to build computers. I started with that. Maybe some people know that, what this is. This is a punch card, okay? There were no screens, so human interaction, natural user interface, nothing. We had to type this damned thing on a machine, and we had these punch cards. And I remember my first program, I was writing a program in a programming language called Pascal, which was developed here in Zurich, Professor Wirth at ETH, imagine that. And there was, my first program I wrote at university was 30 punch cards. And I had to put it to somewhere, and after 3 hours, I got a message back that on the third punch card, I forgot the stroke. So my program didn't compile, it didn't run. Okay, so that was my start in IT. And I said, never. Okay, so this was the time when the interaction you had with the computer, and this is only 40 years ago, was no screen, no mouse, nothing. It was just like this. You stored data on a tape. You even had hard disks. And this is how you did programming. There are some coders here. Imagine how you do codes like this. Okay? So, and then, oh, there was a time. Maybe some people remember that. There was a time before the telefax. Anybody still using telefax? Yeah? Yeah, okay. But it's going, yeah, okay? So, but this was before telefax. It was called telex. Okay, so it was a 5-bit operating system there, or 5-bit characters, how you coded that stuff. And at this time, we were developing software with punch cards or whatever, and when we were communicating with the US, we had to use this telex. That was the way how we communicated. And we had a reader who was taking this bit, and then based on that, we understood what the other guy was telling. Okay, and now the world is changing, right? So, it changed, yes, but I think, so we have still, if you look here, maybe you see that, so these are all zeros and ones, nothing else. So the whole computer industry, everything we do, everything we code, we just say something has a state of 0 or 1. Is this intelligent? I don't think so. Artificial intelligence, where we just say something is 0 or 1. Okay, this is science fiction, artificial intelligence. We are the people who do code. We do the programs, and we are whole human beings. We have our problems, our mistakes, our faults. So programs also have their faults, and they crash. So that's the reason why. Hardware, do you know how hardware is produced, how these processors are produced, how they are cooking the chips in a bakery, with, so to make them artificially older and to find out how long, for example, an i5 or i7 processor, a processor in your phone is running and is able to run. And do you know how many errors there are in such a processor? There are millions of transistors. Every processor on the market, which is out at the customer side, has mistakes. And so sometimes a computer crashes. It can be software, it can be hardware. You have no idea why. This is because we make it. And we are human beings. Okay? So, but we are a little bit more complicated, right? So we have our DNA. Okay? So this DNA stuff here, which is not binary. It's not 0, 1. It has some more characters, right? And we start now to play around here, yes? So we say, oh, we start now to bit on, bit off, or make a gen in the DNA, something plus and minus. And this will be very interesting to understand how the whole pharmacy will work with that. I don't know. But I think we don't have really to be afraid. Oh, okay, I don't need that anymore. Okay, so, anybody afraid that the computers will take over, that they will control us? If this is 0 and 1s at the moment, not with that architecture, not with that computers we have today. No way. Okay, so how do we see now what is now happening and what is the near future? So we have this transformation from the graphical user interface. Oh, we had that before, yes, with the punch cards. And after the punch cards, we get these screens, character-oriented, black and white or green, and then you had these characters. And I had the Apple I. I sold it. Okay, I should have kept it and sold it now. So I had an Apple I, and we wrote a program where we had the cursor going around like this, and we were really happy as programmers. Okay, no user interface at this time. Then the graphical user interface was coming. So we had this developed by Xerox, okay, and then Apple adopted it, Microsoft used it for Windows, IBM used it for OS/2, and so on. And so this was the graphical user interface, and this interesting thing what happened is that people at home bought the PCs or Macs, and they said, why the hell do I have to work in my business with character-oriented applications when I have a mouse and I have a graphical user interface? And that was the start of the success of Windows or the other operating systems which had the graphical user interface. I think now, oh, what's that? Is this from CollaBoard? Users? Okay, good. So, graphical user interface slowly starts to stop now. That's what I think. So the next step is this natural user interface, and the first product we've shown you today was CollaBoard. And what we do now with CollaBoard, or the technology we use here with this natural user interface, we are going to implement that in our other applications. Like in our My Company or eInfo or CRM, ERP applications, we are implementing this so that in the future, users can work with the natural user interface with their application they have now. And I think this will change the software industry. So the people who will stay with the graphical user interface in a few years, they will say, look so old, look so old. It's not the way we want to use it, okay? A lot of you have at home an iPad or such a device, and they started to work with touch and everything. And in the application used in the office, you can't use touch, right? Okay, so this is what is happening now. And just touch, most of the people, if I talk with them and I say touch, then they say, oh yes, it was coming with the iPhone. Okay. Well, there was in 2000, John told about this, was this Microsoft tablet we were using in hospital writing software for that, where you had touch. But the theoretical approach for that was in the 60s. In 1960-something, a guy wrote down what is touch and made a patent. I don't know if he gets money out of that, but so the whole theoretical approach is from the 60s, and we were able in 2000-something to produce devices which are touch-enabled. And you know why touch is so cool? Do you have an idea? Touch is something which is built into our operating system as human beings. Okay? Look at a baby. If the baby looks at the mother and it does like this is touch. Okay? So it's built into ourselves. Or if we have eaten something, then we do like this. Okay? So it's touch. Touch is a natural motion we use. Keyboard, mouse? I don't think so. So this is why natural user interfaces are coming now and are the future, or even here. Then something else is going now to happen. So we have these smartphones. I think 2016 is the year where the smartphones start to decline. Okay? So there will be new devices, not smartphones anymore, which we will work with. So I think if we look ahead in 10 years, and the children who are born now, in 10 years or in 20 years, when they are grown up, they don't know what a smartphone is, because they will be replaced by devices and a mass of devices. So we have seen this, not the HoloLens, the other stuff. So yeah, okay. So HoloLens is one of these. Okay, but I mean devices. So we know this thing, right? something like that, where we say, like the Surface Hub, so we have several touch devices and so on. But we will have things like this. So this is Google Lens. Oh, where is it? Oh, I put it in here. Okay. So Google has a patent on that. So it's an optical lens. On the optical lens, you have a chip, and you have a computer here, you have sensors here, and they are detecting glucose in the tears. So if you have diabetes, it can react to that. So this is just one of the prototypes of devices, but these are already here. So this is going to happen, okay? Or this kind of stuff. I don't know if I like that, but so I don't know if I want to have the chip implemented here, okay? But technically, I mean, there's a professor in the UK who did that already, and it's not only just measuring your blood pressure or whatever, it's also measuring your feelings, okay? So, emotions. So, this is scary, okay, yes, but this is what is happening now. I mean, now it means it's in the, people are working on it. It's not something we are thinking about it, okay? Then we have this mixed reality and holograms. I believe in holograms, because what holograms is, we have now the two-dimensional screens. Also here, everything is two-dimensional. You try to rotate, you can rotate. But the next thing is, like with the 3D printer, a lot of cars already have parts which are produced by 3D printers. Consumers doesn't know. So the next step is, I think, that you will have holograms and you will have three-dimensional stuff, and you work with the three-dimensional stuff also in your applications. Okay? And the question is, should I invest now? Should I invest in all these new emerging technologies? Which one will be successful and which one will crash? Nobody knows. So what we have now here is the Surface Hub. The Surface Hub works, and I'm sure you have a very high return on investment on the Surface Hub, together maybe with CollaBoard. So there you can make really a big benefit for your company. HoloLens, as a consumer or company, I only would invest in a prototype, try something, but not do something on it. I like the HoloLens, but it's heavy. It's 600 grams. So if I have it on my head for more than 2 hours, I'm tired. I feel pain here. So this is not the way it will be. It's a developer device. There will be new devices maybe in 1 or 2 years, which will completely change. So I would say, yes, invest into the stuff which is already working, and let the other guys like us work on the stuff which is still in production. Okay, now, this is my last thing. So, okay, so this is the near future. So how does the future like in 10 years? So when we say 2006, there was no iPhone. So what do you think? What do we will have in 10 years from now, in 2026? Okay, I think that it will, oh, where is it? In which one? Oh, yeah, I see. Okay. So, we had these 001s, which all our computers are based on now. This will change. It will explode, like here in this picture. Okay? It will be complete new concepts for computers. You have to understand, a computer today is still based on the von Neumann Rechner. And this is an architecture which has been made in the 40s or 50s in 19-something. Every computer is today based on that. Nothing really new. It's just smarter, it's faster, slower, smaller, but it's still the same concept. So something new has to happen. And so I come here to a little bit of philosophical stuff. So this is, maybe some of you know that, okay? So this is a Chinese picture of the Tai Chi or the Yin Yang. Why do I present that? So they had, several thousand years ago, they had this black and white, sun and moon, man and woman, 0, 1, okay? Leibniz, in this time, in 1600, the Jesuits went to China and were reading about this philosophy came back, and we know today that Leibniz was reading these papers, and we think, or a lot of people think, that the binary system he developed was based on that. You have 0, 1, black and white. Now, if you look into that picture, yes, it's white and it's black, but in the white, it has some black. So the 0 has a little bit of 1, and the 1 has a little bit of 0. Can you imagine that? So it could be something that the computer, something is not just 0, and it's not just 1, but it can have several states, and this is what is happening now. Okay? So this is where we are talking about new physics, which is based on the relativity theory and some other things. So we had the classical bit, 0 and 1. And now the new thing is this qubit. And now imagine if you have here this Earth, or this three-dimensional object, that between the 0 and 1, it can have endless states. Okay? So if you are able to put that into a new computer architecture, okay, then you can store massively much more data, and you can do calculations much, much faster than ever possible. Okay, so if you're interested in that, then you find in the internet a lot of things about qubits. So these qubits are not only theoretical stuff, but there are the first computers already running with that. Okay? And you can understand who are doing this. So maybe Google, Microsoft, Apple, I don't know. But what I know is that military things are working on that. And you have to understand, the power we will get here with this architecture is really exponential, which means the first guys who will have a qubit computer, which is not just in the test field, but is working, they can decrypt anything what is today encrypted within seconds. Okay? Because you know what encryption is? Encryption is just you have an algorithm where you're changing some bits, and then you are not fast enough to encrypt. So if you have a computer which is fast enough, it will decrypt everything. So the first military service who will have such a computer, they can read all the encrypted stuff worldwide. Okay? So this is what is going on. But this is a bit far away. I think we will have the first computers based on this technology in the next 10 years. And then connected with devices, this will really change the complete world. This is what I think. But if you go back now, so we are now in 2016, we have a lot of new interesting stuff which is already working now. So I think the next step is that you can test or play the people who want to get also an experience how Surface Hub works, and also on the HoloLens, so can a little bit try what is today possible. And we will make, in the future, we will make other events where we will talk to you what is going on and what is happening. Thank you very much.